graphing. So graphing is one of the things you do a lot in math, and there's actually a couple methods to do this depending on the type of equation we're dealing with. But today we're going to talk about making XY tables. So, given the equation, for example, y equals x minus 2, we want to produce a graph. So, we have our XY coordinate plane, and we'll just start by putting a couple tallies in each direction. So we are going to build ourselves a table. So we need x and we need y. And to create this table, we are going to select or pick our own values for x and find out what y equals depending on what we pick for x. So say, for example, I pick an x of -1. Well, y is equal to 1 minus 2, or excuse me, -1 minus 2, or -3. So, remembering from our ordered pair video and graphing them, we would remember that x of -1 is over here, y of -3 is down 3, and so this point -1, -3 would be down here. Let's pick another point. Let's say 0 for x. Well, we get 0 minus 2, or -2. So, 0 in the x, down 2 in the y, and our second point is here. Let's do one more just so we can emphasize how this graph looks. So, let's say we pick 1 for x. Well, 1 minus 2 equals -1, so we get a point of 1, -1, and our third point is here. Since this is a linear line type of graph, these 3 points, and actually 2 points, is enough to create a graph. And so, connecting our 3 points, knowing that the graph will continue the same pattern in both directions, there would be our line. Let's try another one. Let's say, for example, we were given the equation that's nonlinear. Let's say it's x squared plus 1. And later you'll get more into this, but this is referred to as a quadratic function. So, given our coordinate plane and a couple tallies to get us started, so we know what the graph kind of looks like, let's create an XY chart. So x, y, starting with, let's pick the same value, -1. If we put -1 in for x, we get -1 squared plus 1, or 1 plus 1, which equals 2. Big thing here, remember -1 squared is a positive 1. It's not uncommon to see people make the mistake and think -1 squared is negative, but it's actually positive. So we get the point -1, 2, or -1 in the x direction, 2 in the y, first point. Let's put 0 in. 0 squared plus 1 is 0 plus 1, or 1, so we get the point 0, 1. 0 in the x, 1 in the y, second point. Sticking 1 in for x, or substituting, we get 1 squared plus 1, which is 1 plus 1, or 2. So we get the point 1, 2. So 1 in the x, 2 in the y. And we'll notice that this type of a graph takes on a U kind of shape. You'll notice that quadratics all have this same type of general shape as you graph them, just like lines or linear graphs look like this in general. Let's try one more third example. Say, for example, we wanted to graph y equals absolute value of x. So, if we remember what an absolute value does, it tells you how far away from 0 something is, or in other words, it makes any number in it positive, in a simple way of putting it. So if we create an XY table for this function, and we put, say, -1 in for x, well, absolute value of -1 is 1. So we get the point -1, 1. So -1 in the x, 1 in the y, our first point. Sticking 0 in for x, we get absolute value of 0 is just 0. So the point 0, 0 would put us at the origin. Graphing a third point, sticking 1 in, we get 1, 1. You'll notice on these 3 examples, I went with the same 3 values for x. You don't always have to do that. I've typically just gone with those because I found a lot of times 1s and 0s make for simple work in terms of solving. We could have just as easily stuck 2, anything else in here, and got absolute value of 2 is 2, so we have the point 2, 2. And it looks something like this. And these types of graphs typically take on a V shape. So once again, XY table, you pick values for x, plug them into your equation, you find out what y is in those cases, plot your points on your coordinate plane, and connect them to create your graph.